In this video, I'll be showing you how to solve a system of equations. First, I'll take two equations that have both x and y in them. In this case, I'll have 4x plus 6y equals 14 and 2x plus 4 equals 8y. Now there are many different ways to solve systems of equations. In this video, I'll be showing you three ways. The first will be setting the equations equal to each other. I'll call this way the equivalent equations method. To do this, I have to take each equation and solve it for y. So for 2x plus 4 equals 8y, I divide everything by 8 because it will leave y alone with a coefficient of 1. I am then left with 0.25x plus 0.5 equals y. Then for the other equation, 4x plus 6y equals 14, I subtract 4x from both sides in order to isolate y. Then I divide everything by 6 in order to leave y with a coefficient of 1. Now with the two equations set equal to y, I can combine them. So, now that the two equations are set equal to each other, I begin to solve them. First, by getting all the x's and the constants on separate sides. Constants are numbers without a variable coefficient, like x's or y's. Then once the sides are separated into constants and x's, I divide each side by 0.916 repeating to give me the final answer of x equals 2. Once I have found the answer for x, I can find the answer for y. I do this by plugging x back into the original equation. After some simple algebra, it comes out with an answer of y equals 1. The same answer of y equals 1 is also derived from the equation 4x plus 6y equals 14. Thus, the final answer is x equals 2 and y equals 1, or commonly shown as the coordinate 2, 1. Another way to solve a system of equations would be the elimination method. You can solve this method by either eliminating the y or the x variable. I'll first show you how to eliminate the y variable. So I look back at the point in the last method where we solved each equation for y. I take those equations and place them one on top of another and orient the y's so they're in a vertical line on top of each other. I then subtract the equations as if they were one large subtraction problem. The y values equals 0.916 repeating, the constants subtract into 1.83 repeating, and the y's cancel out to 0. I then solve the equation for x and find that it equals 2, just like I did before in the last method. I do the same steps of plugging x into one or both of the original equations to get the y value of 1, and therefore the same answer, 2, 1. The second way to solve an equation with the elimination method is to eliminate the x's in the equation. To do this, I have to make sure that the x coefficient is the same for both equations. In order to get this, I multiply the bottom equation by 2 so that the x coefficient goes from 2 to 4 and all the other values in the equation are doubled. Once I do this, I orient the equation so that the x's and y's are in a line with the equation above. Then, I subtract the top and from the bottom and eliminate the x's, getting 22y equals 22. I then divide by 22 on both sides to get an answer of y equals 1. By then plugging this back into one or both of the equations, I solve for x and get 2, a final coordinate of 2, 1. The third and final method is probably the most popular method used for solving systems of equations. It's called the substitution method. To perform this, I start with the original equations and solve for y or x for one of the equations. In this case, I'll solve for y. Once this is complete, I take that value for y, 0.25x plus 0.5, and plug it into the y value for the other equation. After doing this, I'll simplify the equation and solve it until I get the final answer of x equals 2. And, from earlier in the video, we know that this is the right answer and eventually gets us the answer of y equals 1.